Hello, this is Dr. V.C. Sontake and I am the course faculty for the course Engineering Thermodynamics. The objective of this video lecture is to explain the concept of quasi-static process and its significance. So, let us discuss quasi-static process. In order to discuss quasi-static process, first let us consider a cylinder having stops at the top of its mouth. It contains a piston. The piston and cylinder contains a gas with initial pressure P1, V1 and T1. And let us say a weight W is placed on this piston. The weight W is such that it balances the pressure force exerted by the gas. So let's say this represents the initial condition of the gas as thermodynamic system. So the diagram will represent transition between two equilibrium states by an unbalanced force. Now I can represent initial condition of this gas as a thermodynamic system on property chart PV diagram. So let's say this represents initial condition of or initial state of the system having properties P1, V1 and T1. And pressure is P1, volume is V1. Now the weight W is removed, so unbalance will be created between gas pressure force and the weight, and because of which piston will be moving in the upward direction till it hits the stops. Let's say at this point of time gas pressure is P2, volume is V2 and temperature is T2. So this will be the final state of the gas, and I can represent this state on property chart having properties P2, V2 and T2, and pressure and volume will be P2, V2 at this condition. So what can I say? Initial state and final state both were the equilibrium conditions, and system has undergone change of state from state 1 to state 2. So I can say something has happened between state 1 and 2 because system has undergone change of state. But I don't have any idea about the intermediate states passed through by the gas as a system during this change of state from equilibrium state 1 to equilibrium state 2. So thermodynamic is not able to tell what has happened between these two states and how the properties of the gas have changed because of this change of state and in between intermediate states. So according to thermodynamics, it is unable to tell what has happened to the system and its properties during the intermediate states because they are not equilibrium states. Now, in another case, the single weight on the piston is made up of many very small pieces of weight. The entire weight W is divided into a small number of 4 weights. So let's say in this condition, the gas pressure is P1, V1 and T1, and initial state of the gas is equilibrium state and represented on PV diagram by state 1. Now in next condition, first weight is removed, so there will be some unbalance created, and because of this piston will be moving in the upward direction under the influence of gas force. And let's say at this condition gas pressure is P2, volume is V2 and temperature is T2, and this state is once again an equilibrium state. Now why I am saying it is an equilibrium state? Because the weight of the piston what we have removed was very small, infinitesimal, and because of its removal, infinitesimal change has occurred, because of which piston has moved infinitesimal in the upward direction. So the new state occupied by the piston is once again an equilibrium state, and I can represent this state on property chart PV by state 2. In another instant of time, we have removed the second small weight. Once again, unbalance will be created and piston will be moving in the upward direction infinitesimally and will stop. Let's say at this point, the new pressure, volume and temperatures are P3, V3, T3, and new state occupied by the piston and weight is an equilibrium state, and it is represented by state 3. Once again, weight 3 is removed, unbalance will be created, piston will be moving in the upward direction infinitesimally, gas will occupy new state having pressure, volume and temperature P4, V4, T4 respectively, and the change has occurred infinitesimally. So this will be again an equilibrium state represented by state 4 on PV diagram. Now finally, this weight is also removed, unbalance will be created and piston will be moving in the upward direction till it hits the stops, and gas will occupy new state having properties P5, V5, T5. Once again, piston has moved infinitesimally, its properties are changed infinitesimally, so new state will again be an equilibrium state represented by state 5. So what we have done actually, we have made the piston to move from initial equilibrium state to the last equilibrium state, which will be till the piston hits the stop, by going through different equilibrium states. Why I am saying equilibrium? State 2 is in equilibrium with the state 1 because the changes are infinitesimal. It has changed the state 2 from state 1 infinitesimally. Very small changes in the properties so that state 2 can be in equilibrium with the state 1. Similarly, state 3 is in equilibrium with state 2, 4 is in equilibrium with its previous state 3, and 5 is in equilibrium with state 4. So what system is doing? System is undergoing change of state by succeeding through equilibrium states. So if a system is undergoing change of state or executing a process by succeeding through different equilibrium states, such process is called as quasi-static process. So here process 1, 2, 3, 4, 5 will be quasi-static process. So what exactly quasi-static or quasi-equilibrium process? When a process is carried out in such a manner that the system remains infinitesimally close to an equilibrium state at all times, it is called quasi-static or quasi-equilibrium process. Quasi means almost. So quasi-static process meaning it is almost static. The process takes place so slowly that it appears almost static. However, the process is taking place. A quasi-static process can be viewed as a sufficiently slow process. A quasi-equilibrium process is idealized process and is not a true representation of an actual process. It is an hypothetical and ideal process. Infinite slowness is the characteristics of the quasi-static process. It is very slow process. That is why it appears almost static. It appears as if it is not occurring at all. Now, engineers are interested in quasi-static or equilibrium process for two reasons. First, these processes are easy to analyze, and second, work producing devices deliver most work when they operate on quasi-equilibrium processes. Therefore, quasi-equilibrium processes serve as standards to which actual processes can be compared. Now, example of quasi-static process. There are so many practical examples which can be considered as quasi-static process for the sake of illustration. Like darkening of skin color in summer. For example, if you observe your skin of a color in February month and you will observe the skin of color in the month of June, there would have been significant difference. But during each day of February, March or April, you will not be able to identify or distinguish the change in the color of your skin with respect to the previous day. Though it has changed, but you are not able to figure out because the change in the color of the skin is so minute, so infinitesimal, it almost appears as the same color with respect to its previous day. But if you observe as a whole, as a process of change of color of skin from the month of February to the month of June, you will find there is a significant change. So I can say darkening of skin color, every day the change of color is an equilibrium process with respect to its previous day, and changes are taking place infinitesimally small, and the process of changing color is so small, so slow. That is why it can be taken as a good example of quasi-static process. Then fading of cloth colors over the period of time, same thing. You cannot identify the change in the color of your clothes with respect to the previous day. But in the month, for 4 to 5 months, what you will observe, the colors of the cloths have been changed or faded significantly. Emptying cooler tank with the help of a small teaspoon. If you have a 20-liter cooler tank and you have asked someone to empty it with the help of table teaspoon, so he will remove few drops. So it will be difficult for you to observe is there any change in the water level of the tank. But it is changing, but it is changing so slowly, so infinitesimally, you will not able to figure out with respect to the previous water level. But after 1 or 2 or 3 hours, you will find the cooler has been emptied even with the help of teaspoon. So again, it is a quasi-static process. And decrease in the water level in the pot. So there can be many examples of quasi-static process from the real life situations. Okay. So with this, after watching this video, you will be able to learn or to explain quasi-static process and its significance. With this, I come to an end of this video lecture. Thank you for your kind attention and passionate listening. Happy learning.